Yes, teacher.
Please lead us in an opening prayer.
Let's humble ourselves and pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Heavenly Father, we come before you this afternoon. Thank you for the gift of life and each and everything you have done for us, Lord. As we're going to begin this lesson, we pray that you may help us understand each and everything and put it into practice, Lord. And we pray that you may also show us our purpose in life so that we may be able to be important people. We ask all this through Christ our Lord.
Amen. Thank you very much.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Amen. Okay. So, thank you for the beautiful prayer you have given us. So we are waiting. We are only 3 have already joined, but we shall wait for those other people to come in. Since we covered some few properties last time of these circle properties, some few, like 2 of them, I can remind you basing on some of these questions which are here. So we looked at the properties of these circles. The first one, if you can remember, we looked at the chords, and also these chords have their own properties. So one of them, one of the things that we said is that the perpendicular bisector of the chord of a circle passes through the center of the circle. So if this is the chord AB and we are bisecting this line AB into 2, then the line that bisects it must pass through the center of the circle. The part B was the perpendicular drawn from the center of the circle to the chord bisects the chord. So this bisector here, the line OM, bisects the chord AB into 2 equal parts. So that means that AM is equal to MB. Then they also told you that not in both cases the angle at the center is bisected by the perpendicular bisector. So the angle at the center of the circle is also bisected by the perpendicular bisector. So this angle which is here will be divided into 2 equal parts, such that this triangle AMO has an angle here will be the same as the angle which is here. Then the other one was that equal chords are equidistant from the center. So if you have chords, if these chords are equal, they're equal in length, that means that AB is equal to CD. Those chords are equal, and if they are equal, then it means that they are also equidistant from the center. So from the center to point N, from O to point N, and also from point O to point M, those distances are equal because the chords are also equal in length. Okay, so we had a question. The other question we had was about this kind of sector, the sector, and then the triangle. We say that the triangle which will be formed is the triangle OXY. If I may zoom in there for you very well, and you see. So triangle OXY. That triangle is what? Is Alexandria. Triangle OXY is what? Which name is given to triangle XY? Correct. It is an isosceles triangle. So XY is an isosceles triangle. Reason is that the distance OX is equal to the distance OY. Why? Because those distances are radii of the circle. So OX and OY are radii of the circle. So that means that if we join those 3 points OX and Y, we form an isosceles triangle. What does that one mean? It means that the angle at X here will be equal to the angle at Y here. Now, the other thing that you should know is that if it is an isosceles triangle, then the angle that is at O here is bisected into 2. That's what we looked at. It's bisected into 2 equal parts. Then, what else should you know? You should know that if we have a line XY which is drawn, then XY is a chord, and a chord will create 2 segments We'll create the bigger segment. This one, this other side, this is the bigger segment, and we'll create a smaller segment or the minor segment. So this is the minor segment, and this one is the major segment. So remember very well that if we have a code that is drawn and it has created those two segments, then this line that bisects that code cuts the code into two. The other thing that you should know is that when we draw the two radii OX and OY, they create two pizza-like shapes. Pizza-like shapes. I know you like pizza. Pizza-like shapes. So you can see X or Y, this shape, X, Y. I'm talking about this one. I think you can see my cursor, how it is moving. That shape there. It is in pizza-like form. So that is what we call a sector. And because it is very small, compared to this other one, this other side, the left over. So it means that this is the major sector and this is the minor sector, So if there is a code that is drawn, it means that it creates a segment, a minor segment here, which this minor segment here is part of the sector. The minor segment XY, this one here is part of the sector. If I may draw it for you, this part here they are talking about, that one there. If we have X here and we have Y, so this part here is the minor segment, and but the whole of this, something like this, the whole of this is what we call the sector. So the whole of this is what we call the sector. The whole of this is what we call the sector. But you should know here that here we have an isosceles triangle, and here we have a minor segment. But the whole of this is what we call a sector, and that sector is a minor sector. So you can be told to find the angle, to find the area of this shaded part, or to find the area of the minor sector. So what you have to do is you have to get this, you have to know this angle here. If you don't know that angle, then if this distance XY is given, so you can get the angle. So say this is 90 degrees. So you can use Pythagoras theorem and then get the angle which is here. If you know this distance and you know this distance here, which is the radius. The other thing that you should know is if you want to get to the shaded area here, then it has to be the area of the whole sector, then the area of this triangle here. So that's what we looked at, that if you want to get to the area of the shaded region, then it's going to be the area of the sector, minus area of the isosceles triangle. Okay, and the area of the sector is given by, if this angle is theta here, then the area of the sector is given by theta out of 360 times pi r squared, whereas area of the isosceles triangle is given by a half. This is radius and this is radius. It will be a half times radius, then times sine theta. And when you get the answer to this and the answer to this, and you subtract, you get the area of this shaded region. All right. So let us see what we are supposed to cover today. So we are supposed to look at these properties of circles one by one. And I'll be giving you each example. Every property we shall be looking at one example, and then we understand very well how these properties are used. So let us start with the first property here. The first property is that the angle in a semicircle is a right angle. So the first one, so we are looking at angle properties. Cool. Good afternoon, those people have just joined in. People have just joined in. Good afternoon. Letitia, Patricia.
Good afternoon, teacher.
Okay, can can hear you. You are very swaggerific. Okay. All right. So they are saying that number one, the angle in a semicircle is a right angle. So angle, come on, there's n here. Angle in a semicircle is a right angle. It's a right angle. So the angle, the angle in a semicircle is a right angle. The two things you must note. And here they have just drawn for you the diagram, which is here. I may not draw it for you, but we shall look at the example. So you can see that this line AB is a diameter, and it means that this other side ACB is a semicircle. So ACB is a semicircle. So it means that the angle that is inside this semicircle is a right angle. We have said a semicircle, and we should note that a semicircle there must be a diameter, and the line we are looking at, the line there must be a diameter. So there must be a diameter for this rule to apply. Diameter will create a semicircle, and the semicircle, if there is any angle within that semicircle, that angle is a right angle. Come on, let me draw it for you to have a picture of how your notes should look like. Wow, 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 wow. Letitia, do you have a set there? Do you have a geometry set?
I'm going to get right now.
Yeah, you get right now. I know Sherry has, isn't it? Sherry has a set. I will not ask, but Sherry has a set. I know that. Sherry, isn't it? You have a set. I will not ask Sherry, but you have a set, isn't it?
Yes, teacher.
Very good. You see, I was right. So we have this, and this is A, this is B, this is 4. So any angle that is drawn within this semicircle here, for example, this one here, okay, so this is 90 degrees at point C. Come on, we can draw another one inside this semicircle, and we see. Can first note this one down and say the angle ACB is 90 degrees. You can also put another one here. Let me show you. You can put another one here. So also angle, we call this one D. Angle ADB is also 90 degrees. I feel like getting a protractor and measuring this. Let's see. Are you seeing that? It's 90 what? 90 degrees. Even here. Even this one is 90 degrees. So, or is the angle inside here will be 90 degrees. So example. So I'm going to take you to this example here. Example 3.4, somewhere here. Let's go 3.4. Okay, example. So you're saying that in the diagram, in the figure, so in the following diagram, AB is the diameter of a circle. Center O, find the angle B. So that's the first example. You can say example. They're saying that in, huh? Okay, in the following, just copy the question. In the following diagram, comma, AB is a diameter of a circle, center O, then find angle B, telling us to find the angle B. So have the question drawn, have the diagram drawn, so that you know what you are seeing, what you should have in your notes. That, so we draw that, and we have this, and we have that. Okay, so this is A, this is B, this is O, and this is C. So they have told you that this angle here is 37. Zoom in there and you see. I want you to see very well. That angle there is 37 degrees. So applying this kind of law that the angle in a semicircle is a right angle, then it means that here, this is a semicircle here. So it means that this angle here is 90. Come on, it's 90 degrees. 90 degrees. So what we are supposed to do, if they want us to get the angle, which is here, angle B, then we are going to apply some of our P1 mathematics, and we are going to say the angle sum of a triangle is what? Members, are you there?
Yes.
Angle sum of a triangle is 180. So we shall have B. Okay, I know the problem is network. So we shall have B plus 37, then plus 90 equals to 180 degrees. So B plus 37 plus that, what we get? What do we get? Who's faster than me?
100.
100 and what?
127.
Very good. 107 is equal to 180. So it means B equals to 180 minus 127. And our B shall be equal to
53
53.
degrees.
Correct. So that is the first property that you should know, that the angle in the diameter, the angle in the semicircle is always 90 degrees. Always 90 degrees. All right. Okay. So why don't we proceed and look at another thing? But before that, let me. I think you have understood that. Have you understood that very well, members? Members, have you understood that?
Yes.
All right.
Yes, teacher.
Correct. So let us go to the next part. And our next part is number 2. So what is number 2? They're saying that angles in the same segment of a circle are equal. Angles in the same segment of a circle same segment of a circle are equal. And in brackets, they are saying that the angle subtended by an arc in the same segment of the circle are equal. So angles subtended by the same arc in the same segment. Hey, angles subtended. It is also important. Subtended by an arc in the same segment circle, co equal. So let us look at this property, one by drawing our diagram here, by drawing our diagram here. So let us draw this and see. I don't know whether you can see. I'm getting some little challenge here, but let me just do this. Okay, so we are going to see exactly what goes on here. If we have this circle here drawn, let us see. Okay, so let us construct, or let us put this kind of angles. So the first one, I'll first draw this. Now, members, AZ AZ is not a diameter. It's not a diameter, so I can do it somewhere because they have not said that AZ is a diameter. AZ is not a diameter. They have not said that the angle. So this is just a line. AZ is a chord. XB is a chord. YB is a chord. ZB is a chord. AX is also a chord. So what is a chord? A chord is a line that joins 2 points on a circumference. A line that joins 2 points on a circumference. So you can see Z and B, that is a line joining 2 points on a circumference. There is also Z and A, just a line joining 2 points on a circumference. There is XB, there is YB, there is XA. So all those are chords. And once chords are created, once chords are drawn, they create what we call segments. So let us draw these chords. So the first one is, let me first draw this one, AZ. So let me pass it on at the center for you to understand that it is not. Okay, so this is A, this is Z. Then I'll have my B somewhere here. Okay, then I'll have Y somewhere there. Then I'll have to come and join here. This is one. I'll get also another chord from B to X. And also this will be X. Okay, like that. So now what you should know is that these angles are equal. These angles are equal. So they have said that angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. Now let us look at this chord AZ. Members, are we together? Let us look at the chord AZ. So the chord AZ creates 2 segments. The center is here, members. The center is here of the circle. So the chord AZ creates 2 segments. Creates this segment this side and this other segment this side. Okay. So it means that we have angles in this segment. This is the segment. This is the segment. This one here. This is not a diameter, but it is a segment. It's a segment. So, yes, question. Any question? So let me remind you what a segment is. So if we draw a line like that, a chord like that, let's say AZ, like that. So this is a segment and it is minor segment. And this one here is a major, major segment. Okay, so a chord creates segments. The smaller one is minor, the bigger one is major. So when you look at this chord AZ creates this segment here, and they have said that angles in the same segment are equal. So we have angle X and we also have angle what? Y, which are in this segment. So it means that these angles are equal. X and Y are equal together. So we have seen that the first one, we have the angles A, X, B being equal to angle A, Y, B. That is the first thing, isn't it? AXB is equal to angle AYB. Why? Because these angles are in this segment here. If I may shade for you that segment, you can see this is the segment I'm talking about.
Shepherd don't need. Please.
Letitia, are you attentive? Letitia?
I'm attentive, but I didn't get you well.
Okay, I've said that.
Even me.
What's the problem? Is it raining that side? I've said that the angle AXB is equal to the angle AYB. So this angle here is equal to this angle. Why? Because these two angles are in the same segment. The whole of this is what we call a segment. This one here, this is a segment, and also this side is also a segment. These two segments are created by the chord AZ. So this is what I was showing you, that if you have a line or a chord, AZ, that chord creates two segments, the minor segment and the major segment. So if we have angles which are there, any angle which is there inside this segment, those angles are going to be equal. So we have an angle there and we also have another angle somewhere there. So these angles, because they're in the same segment, they are going to be equal. So that's why I'm saying that Y is equal to X, because they are in the same segment. Now, the other thing that you should also know is that when we try and we draw a chord XB, see XB is also a chord, this one here, XB is also a chord. So it means that it creates this segment here. Huh? Members, are you there? Are you there?
Yes.
Yes.
Teacher.
Yes.
So XB will create this segment here, and also this other segment at the bottom. Okay. So it means that Y is in this segment, and also Z is in this segment created by this chord. Okay, I'm seeing that chord. So that means that Y is equal to Z. Y is equal to Z. Y is equal to Z because of this chord. So it means that if Y was equal to X, then Y is equal to Z, then it means that AXB is equal to AYB, which is also equal to AZB. So these angles angle X is equal to angle Y, and it is also equal to angle what? Angle Z, because these angles, that first one in the same segment, and also these other ones are also in the same segment. So that is what you have to note down now. Now, which example can we use there? Let's see which example are we going to use there. So let us look at an example, that point, and let us look at example 3.7. 3.7. 3.7. Okay. So do you see 3.7? Are you seeing it here? You're saying that given BDC is 62 and BDC is 62 and this CA is 44, find the angle BSC. BAC and also the angle ABD. ABD. So let us see. So we are using example. We are using example 3.7 for us to understand that. So we have two lines. We have the first one, SC. Okay. So I'll draw also this one here. Like that. Okay. And I'll draw this. So this is 44. This is 62. I'm joining this here. This one. Okay. This is D. This is C. Members, are we together?
Yes.
Yes.
Okay. So I want you to look at this code. Let me try to change it like this. Do you see this code? Sorry, this is B. Okay. This is B. So do you see this code BC? Are you seeing the code BC?
Yes.
BC. So it means that this code BC creates two segments. Creates this segment which is here. This is the minor segment here. Creates a minor segment here, and it creates this major segment that we are seeing here. This major segment. So these angles which are subtended at the arc in the same segment. For example, we have this. Let me show you. We have this. We have that and that. I shall add the red pen. Choose pencil here. We have this and then this. There. Then we have that and this. So it means that now this angle which is here is equal to this angle which is here. Why? Because these two angles, they are subtended at the arc and they are in the same they're in this same segment, and the segment we are looking at is the major segment. The segment we are looking at is created by the code BC. So BC is the code and creating the minor segment and the major segment, this bigger one. But these ones which are subtended at this same arc here, because this is the arc, it means that this angle which is here must be equal to this angle which is there. Suppose someone removes this. I want to do something. Suppose someone covers this part here. You should be able to understand what I'm talking about. If you have to cover this part which is here and remove that line which is there, you should be able to understand what I'm talking about. So you can see that this angle which is here is equal to this angle which is there. So something which appears like this, that if you have if you have a line like this that is drawn, then these angles which are here subtended at the same arc here, and also this one are equal. If you have also this one, and here y is also equal to z because of the chord xb, so you shall have, sorry, because of the, if you also draw a chord here AB, we shall also have this angle here being equal to this angle which is here. So you should know that these two angles are subtended at the same arc and they are in the same segment. If we draw a line here like this, so it means that if we draw a chord AB, then that chord AB creates two segments, the major segment and the minor segment. Then this angle is equal to that angle. All right, so there should come and say that this angle is 62 degrees. So angle, we can say angle BAC is equal to 62 degrees. And the reason which is there is that both are subtended by the same arc. Both are subtended by arc.
Excuse me, teacher.
Yes, please.
Teacher, what made there's a time whereby you called BC the major segment. What made it the major segment?
BC is a chord.
The major chord.
No, we don't have a major chord. We just have chord.